The New York Times has been putting out a lot of great data visualizations and data-driven analyses as it relates to the presidency and the policies of the Trump administration in general. A couple weeks ago, this upshot article from the New York Times caught my attention: why Elon Musk hasn't come close to finding $1 trillion in cuts. And so the New York Times, I thought, did a very interesting analysis where they went and they looked at the major parts of the budget of the United States and thought about what would it take to get to $1 trillion. A lot of the action in January and February and March was around this non-defense discretionary spending, where they were laying off federal employees who were temporary employees or people that had been on the job for less than 2 years. So even if they were able to cut all of that non-defense discretionary funding, they would still only have cut $950 billion. Yes, that's a big number, but they would have still fallen short of the $1 trillion. So, of course, there are other parts of the budget that then wouldn't have been touched by Musk's efforts. And so what the Times did then was to say, well, what would it take to get to $1 trillion? And so they have a series of plots looking at different types of cuts, right? So if you added military spending, and then if you added anti-poverty programs like Medicaid, Obamacare, CHIP, other benefits, anti-poverty programs, farm aid, things like that. And so if you keep going and then add in Social Security and Medicare, but these are kind of things that you don't touch because cutting Social Security, Medicare, defense are kind of the meat and potatoes issues that voters care about. So cutting these things would get a lot of people upset. Of course, it turns out that when you start cutting everything else in the budget beyond kind of these third rail topics, people, of course, get very upset. I was interested in this type of plot. And this data visualization technique is what's called a waffle plot because it looks like a waffle. If you've, I make waffles every other week in my family for breakfast. Every other week I make pancakes. So I guess I go back and forth between something like a waffle plot and a pie chart. And so these are actually rectangular pie charts is one way of thinking about them. One difference between these and a pie chart, of course, is that it allows us to see things in more Cartesian versus polar coordinates. It then also gives us, with this gridding, basically the kind of the cells of the waffle, you can easily count to see how many elements are in kind of the non-cut part of the budget versus the cut part of the budget. The other thing that differs with a pie chart is that pie charts are typically the same size circle, right? And so if these six entities, six facets of this plot were shown as pie charts, you would have 6 circles with each having a 16% wedge taken out of all 6 of those. That would not be very interesting. Instead, what this waffle plot does is it changes the size of the waffle. And by changing the size of the waffle, you get a sense of the overall size or the overall portion of the budget that goes to that element that we're looking at, so like defense or Medicare or Social Security, right? I am interested in doing a waffle plot because I have seen waffle plots come up time and again in data visualization efforts, right? And so I have a couple critiques of this, and so I'm not going to create this exact same waffle plot. So one critique I have is that all of these plots have the same number of columns. There are 50. Yes, I counted them. So there are 50 columns, right? But they vary in the number of rows. And one thing you'll notice if you look very closely, it's most apparent here for other benefits to individuals, is that not all of the rows are the same height. The bottom rows aren't full size, right? And so I think they varied the size of the bottom row so that they could have a complete rectangle. Otherwise, what you often see with waffle plots is that to get the correct number of cells, you maybe lose some of the cells kind of in the upper right or the bottom right corner of the waffle. And so the other thing that this gets me thinking about is why take it off of the rows rather than the columns? I want to be able to compare the magnitude of a deduction or reduction in the budget for each of these categories. It sure would be easier to do that if I'm comparing things left to right versus top to bottom. So again, it's very challenging to compare even like non-defense discretionary spending to defense to know which is has a higher part of the budget, right? Because, how many rows do they have? I have to count, right? Versus if I had a constant number of rows, say I had 4 rows for each of these, and I then varied the number of columns, it would be much easier to see on that right edge how much of the overall budget went to that category. And so that's a change I'm going to make. There are a couple packages out there to make waffle plots. One is called Waffle, and the other is called GG Waffle. I have tried both of them. I could not get either of them to work. I don't know if it's me or what, or maybe it was just R saying, Pat, just make this from tidyverse without using any other packages. And so that's what I'm going to do. So when I look at this waffle plot, do you know what I see? I see a heat map, right? This is very much like a heat map, but instead of scaling the fill color by some continuous variable, we are setting the fill color based on a categorical variable. So basically the dollars or the squares that are being cut are this pinkish color, and those that are kept in the budget are this grayish color. And so what we need to do is think about how we can convert the amount of money that's left in the budget versus what's cut from the budget into a data frame where we'll have an element for the rows as far as the columns that will indicate each cell in the waffle. And then we need to figure out how to tell it whether that's part of the remaining budget or the cut budget. Then what we have to do is figure out how to facet all this so that we can have 6 different panels. And then for each panel, each facet, we're gonna have to figure out how to put in a title. And so this looks very much like a title and subtitle. And so one approach you might think about taking is patchwork. Patchwork allows you to take multiple plots and put them together. I usually like to use patchwork when I've got different types of plots that I'm bringing together, whereas I like to use something like facet wrap or facet grid when the plots are of the same type. So I'm going to use facet wrap, I think, to do this. So I think I can get this title subtitle appearance for each of the facets using something from ggtext, which would be element markdown, right? And of course, we'll use something like element text box simple or element markdown for the title as well to be able to bake in this change in the font color. So one thing I didn't mention is at the very bottom here is a legend where there is a square box, and that square box indicates that each box represents $5 billion in projected fiscal year 2026 spending. And so defense and non-defense discretionary amounts represent budget authority. I'm not totally sure what that means, but anyway. The other thing is that interest payments on the federal debt are not shown because you got to pay that no matter what. That's not going to get cut. And so I started looking around for information from the Congressional Budget Office. I tried to look at stuff by Richard Kogan from the Center on Budget and Policy Priorities. I didn't find anything there, but I did find some stuff at the Congressional Budget Office, the CBO. And so I was able to find this PDF. I will put the link to the New York Times article as well as this PDF down below in the notes for today's episode. And so this is the PDF showing, again, these different categories that align very well with what we saw in the New York Times plot. So then they have the average percent GDP for each of these categories between 1975 and 2024, as well as the actual values for 2024, and then the projected for 25, 26, and 35. And then there's also billions of dollars for 24, 25, and 26. And so the data we want is here in this 26 column. And over here in RStudio, I have already created an R script called budgetwaffle.r, where I have these different categories. So for example, this non-defense category, I have $1,031 billion. That's $1 trillion and $31 billion, right? And so if you come down to this non-defense discretionary of 1031, that's where that number is. And then defense is at 866, and we see that, right? And so you can kind of do that for these other values as well. And so this is what we are going to use to go about making our waffle chart. I have also loaded in here the tidyverse and show text to get the Libre Franklin font loaded as the Franklin font. That appears to be pretty close to what the New York Times uses in their data visualizations when they use a sans serif font. I'll go ahead and load that. I've also got a GG saves statement here, saving the file as budget waffle PNG with an aspect ratio that more or less matches what I was able to pull out of the web page. And so this is what I have as kind of my muse. I'm not going to make this exact plot as I mentioned, but I'm going to use this to kind of inspire me in my journey to go about making this plot, okay? So the first thing I need to do is figure out how to incorporate the percent cut. So I'll make a column percent underscore cut, and all the values are going to be 16. So I'll copy and paste this down for the various categories. And we need a comma here as well. We'll go ahead and modify this using mutate. So I'll do bill cut as billions times percent cut divided by 100, right? And so that, of course, is our budget variable now. And we see we've got the bill cut and the billions. We'll also have to have bill remain, and that's going to be billions minus bill cut. And again, if we look at budget, we now see that we've got those two columns, bill cut and bill remain. And this is then what, again, we're going to use to feed into our waffle plot. So I'm going to go ahead and clean this up a bit. I'm also going to remove my assignment to budget because when I'm doing this pipeline development, it's kind of annoying to save things back to a variable because then I load that code chunk and then I have to call the name of the variable. It just gets a little tedious. So let me kind of show you what I mean. If I go ahead and remove that pipe then and run it, I automatically get the output. So I want to clean this up to get the category, the bill cut, and the bill remain, because that's what I'm going to use to ultimately make the plot, okay? So let's go ahead and do select category, and then bill cut and bill remain. And we'll also then go ahead and pivot longer. So we'll pivot longer to put the bill cut and the bill remain into a single column rather than in two columns. So we'll do pivot longer minus category. It'll do values 2 equals billions and names 2, we'll say budget. Oh, so it's complaining that bill remain does not exist. And I noticed that I misspelled bill remain up here where I defined it. Now it's not happy that names 2 must be a character vector. All right, so I think I need to wrap these in quotes. All right, a little bit slow getting going here, right? So now what we have is we have the category, the budget, and the billions. And so what I'm thinking is that I will facet on the category, right? So each panel within the plot will be a different category. And then I will change the fill color based on what it is in the budget, whether it's bill cut or bill remain. And you know what? I'm going to go ahead and make this simple I'll say cut equals bill cut and remain equals bill remain. And that's just going to make that column a little bit simpler and easier to read. Anyway, naming things is hard, right? All right, so now what I want to do is think about how I can take, say, like 165 or 866 and turn that into a waffle plot. And so the first thing I'm thinking about is that each square in my waffle plot, I want to be $5 billion. So what I'm going to do then is take that billions column and divide it by 5, or divide it by a scaling factor. I'll call scale factor. I'll say 5, so it's going to be $5 billion, right? And get that loaded. And I went a little bit too fast there, all right? But I want to add a mutate to my billions. So we'll do mutate billions equals billions divided by scale factor. And so now what you'll see is that we've got much smaller numbers, right? 33 and 173. So that will then allow for each square in the waffle to be $5 billion. And then these numbers, like this 173 and the 33, will then be the number of cells. One thing I noticed though is that some of these numbers are fractional, right? So like 27.7. And so if you look back at the original New York Times article, you'll notice that they had some cells that were actually fractional. It wasn't a whole square that was colored by whether it was part of the core budget remaining or part of the cut budget. I'm going to do it so that it's a whole square because I think that's easier to interpret. So we'll do round on billions. And I think the argument we want is digits equals 0. So that will round things to the ones place. And so we no longer have those trailing decimal values. And we can use each of these values to indicate the number of cells that we want. So at this point, I think what I'm going to do is focus on one of these categories, right? And so let's go ahead and focus on the first one. Let's go ahead and do filter category equals non-defense. That gets us that. And I will go ahead and assign this to temp. You can use the right arrow or the left arrow, and the direction of the arrow indicates where you want the data to be stored to, the left or the right. I feel like the right arrow is kind of a deep, dark secret that the our aficionados don't want you to know about, but I think it's kind of cool. We'll remove it eventually, but for now, it's pretty nice and it's easier than going back up to the top. So again, we'll do temp. And so what we've got is budget and billions. And what I want to create is a data frame based on this tibble that then will kind of lay out the values for the number of rows and the number of columns. I'm going to make coordinates, right? And so you could imagine doing something like if I had, say, expand grid, and I could do rows of 1 to 5, calls equals 1 to 4, that's going to give me all combinations of rows and columns, right? Now with these coordinates, I could then create a third column, which would be the category that's going to go into each of those cells of the waffle, right? So that's kind of the general idea. And if that doesn't make sense, hang on, it will eventually. So again, the original plot had 50 columns wide and a variable number of rows. I'm going to change it to have a fixed number of rows and a variable number of columns. And so the Social Security is the biggest chunk, and it's got 3, 4, 5, 6 and a smidge. So we'll say 7 rows. I'm going to create another variable. I'll say n rows of 7. And so with that number of rows, if I take temp and I combine the billions, right? So if I go to temp $billions and I do sum on that, I'm going to get 206, right? So if I divide that by n rows, I'll get the number of columns, but again, that's going to be a fraction, right? So I'm going to have 29 columns and a little bit left over, right? And so what I want to do is I actually want to round this up. I want to make sure that it's always rounded up. So if I use the ceiling function on this, then that will become 30, right? Very good. We got 30, right? And so that is the number of columns that I want. So I'll say n calls equals that. And I'm not going to actually fill all those cells though, right? Because this was 29.42857, right? And so if I think about like n calls times n rows, that gets me 210. And if I then subtract this sum, then I'm going to have 4 cells that have nothing in them, right? So I could do expand grid, and I could then do row equals n rows, or 1 to n rows, and I can then do call equals 1 to n calls. And again, that gets me this, and it's got 210 combinations. As we see, it's got 210 rows, right? And then what we're going to have is what are we going to have? Right, we're then going to have this temp data with budget and billions. And so for now, I'm going to ignore the category column, right? So let's go ahead in here and we'll do select minus category. And some of this code I'm writing, I'm going to remove eventually, but I'm kind of getting to a simplified data set because ultimately what I'm going to do is something like a map function where I'm not going to include the category column in what I'm mapping. That's going to stay fixed, right? Basically, we're going to create a data frame with a column made up of multiple data frames, okay? So that's a little bit where we're going. Hang tight if that doesn't make sense. All right, so again, we've got this for our expand grid. But what we'll then need to do is take temp, which is this, and we can then do, let me go ahead and grab this because I'm just kind of messing around here trying to get some ideas onto the screen. We'll do uncount on temp by billions. And so what this does is this is going to repeat each value in budget by the value in the billions column, right? So we should get 33 values of cut and 173 values of remain. Sure enough, that's what we get. So we get cut, and if I then pipe this to say print n equals 40, then what we'll see is, yeah, the first 33 are cut and the rest are remain. Okay, so that then is going to be the column indicating the group that we want to color our data by, right? But again, this only has 176, this has 206 rows, but we know that our expand grid is going to have 210 rows. So we need to add to this 4 rows of NA value, right? So here we'll then do C to concatenate to that. and we'll then do rep NA, and then it's going to be this value, right? So this n calls times n rows minus the sum. So I'll say n NA is that, right? And so then we'll take that and plop that in there. And I think I'm missing a closing parentheses there. And that's not happy because that is, budget is coming out as a data frame, right? And so what I need to do then is bind rows on this and this. And so this then is going to be budget equals that. Will that work? Nope, that's not gonna work. Okay, let's start again. Okay, so we have uncut, uncount. We now have this as a column of budget. And so then we'll pipe this to bind rows, and we'll then make this a tibble, and it's going to be a tibble with the budget column that's repeating NA and NA times. I think this should work now. That does work. And so now we see we've got 210 rows. If I do a tail on this, I see the last 4 values are NA. And then I think I can do bind calls with expand grid. So let me see if this will work. I grab that and pop that in there. Hey, what do you know? It worked. We now have the budget, the row, and the column. Cool. So then this is my expanded data frame that has the coordinates as well as what budget category, whether it's cut or part of the remaining budget or an NA value for each cell in the coordinates. Okay. So all of this, though, I think belongs in a function. What do you think? So I'm going to call this gritter as a function, and we'll go ahead and define the body of the function, and let's go ahead and tab that over to define the body of the function. Let's get some space in here, and we're going to need to go ahead and put in some arguments, right? And so temp is the data. Let's go ahead and call this D for the data. So we'll go ahead and replace temp with D everywhere. We want to leave that. And we could experiment to make sure this all works by, again, saying, once I get this all loaded, that like gritter on temp should work, right? That gives us our 210 by 3 column data frame. I've got a couple other variables in here I haven't defined, right? So n calls is defined in here, but n rows is not. So I'm going to go ahead and create an argument that I'll call n rows, and I'm going to set the default for that to be 7. And maybe because I think I use n rows up here without an underscore, I'll put an underscore in here to make it clear that this is kind of the local variable, and we'll get that. And maybe I'll go ahead and make n underscore calls, and we'll copy that down here as well. And then right here we also have on n underscore rows, n underscore calls. Okay, so there we've got our gritter function. I'm gonna put that back up here at the top, and I think that should work. Make sure it's loaded. And now what I want to do is I'm going to take this stuff here where I filtered, selected, and assigned it to temp. I'm going to comment that out for now. So now I'm going to do a nest on everything except category. And I'll go ahead and call this data equals negative category. And so now what you see is I've got my categories, and then I've got a separate column called data that is made up of those 2 by 2 tibbles with the cut and the remain, right? As well then as a column for the billions, right? So with this nested data, I can then pipe this to a mutate where I can then say waffle equals map. And so then map will allow us to iterate over each row of data, right? And then we will feed this into gritter, right? Maybe I'll call this waffler because we're making waffle plots. Why not call it waffler? All right. And so then we'll say waffler. And again, the default n underscore row is 7. But actually, let's put that to be n rows rather than 7, because putting in 7 would be hard coding it. So let's go ahead in here. Where did I put that? Right here. We'll make n row equals n rows. And now what we see is that in the waffle column, we have 6 tibbles, right? So the first one is this 210 by 3, 175 by 3, and so forth. And so these values should all be multiples of 7, right? And so is 175 divided by 7 is 25, okay? And then 168 is as well, and 182, and 203, and 336 divided by 7, yeah. So these are all divisible by 7. Cool, right? All right, so I'm gonna go ahead and remove this temporary code now, right? And we now have our category, data, and waffle. To get ready to plot it, we'll go ahead and do a select on category and waffle. Get the waffle spelled right. And then we'll do unnest on waffle. And now what we've got is we've got our category, the budget, the row, and the column. And now we're ready to go into ggplot, right? So we'll go ggplot, AES. On the X, we'll do the call, the Y, the row, the fill will be budget. And then we'll go ahead and do geom underscore tile. And then we'll do facet wrap. So we can do then vars on category. Normally I do something like tilde category, but I'm gonna try this vars category, right? So there we go. We've got a start, right? We've got 6 different panels with 6 different heat maps, and they don't look like a whole lot just yet, but hold on, they will. Let's go ahead and say nCall equals 1 to get everything to be in one column, and we'll save this to our PNG. Good, so again, this is a start. There's a lot that we still need to do, but we'll get there. One thing I'm noticing right off the bat is that I have the cut and the remain going row-wise rather than column-wise. So one thought I have would be to come back up to our waffler function, and here I do this expand grid, and I do the rows and then the columns. I think I want to switch the order here to do the columns and then the row. So we'll go ahead and flip that and remove that extra comma. Let's rerun this and see what we get. Now we see that our data are loading column-wise, right, rather than row-wise, and I think that's going to be better. I, though, do want to emulate what they did in the Times article, where they put the remain category to the left, followed by the cut. We'll leave the NA category third, because ultimately I'm going to turn that NA color to be white, so it blends in with the rest of the background. You'll also notice that all of our facets then have the same number of rows. They all have 7 rows, but they vary in the number of columns, right? And so we can certainly get a better sense of the magnitude of the budgets by varying things along the x-axis rather than the y-axis. So I think this is better. All right, let's go about changing the order to have remain, cut, and A. So whenever we want to change the order of things, it's best to do that with a factor. So we will come back up here, and in pivot longer, we create a column called budget. So I'm going to come into this following mutate statement and do budget equals factor on budget. So I'll do levels equals a vector, and then we'll do remain and cut. I don't need to say NA because that hasn't even been created yet, and by default that will go last. So that switched the colors, but it didn't actually change the order of anything, right? So to change the order, I think we're going to come back up here to waffler, and after uncount, we're going to use arrange to sort the data by the budget column. So it'll sort it by the budget column, again, realizing that remain goes before cut when it's being sorted. So let's go ahead and reload all this. And so now what we see is that we have remain to the left, followed by cut, followed by the NA category. Cool, huh? Thinking of order of things, I'm noticing that my order here is different from what they had in the original. Again, in the order, they go non-defense, defense, Medicaid, other, Medicare, Social Security. So again, to change the order of this, we're going to use a factor. So we'll come back up here, and we'll probably do that within this first mutate statement, where we'll come in here and do category equals factor on category. And then these categories are in the order that I want them, right? And so then we'll do levels equals category, okay? So that should be all we need to do to get our order to match what we have here in our data, as well as in the original New York Times. So now we see we have non-defense, defense, Medicaid, other, Medicare, and Social Security, and we are off to a great start. So to get a better sense of the cells within our waffle, to get that waffle appearance, we are going to need to change the border color of the cells in geom tile. So let's come back up to our geom tile. Where are you? Right here. And we'll do color equals white. I'm also going to do show.legend equals false, because that legend isn't going to be the legend ultimately that we want to use, because we want a legend with a single cell in it. Now we have our cells with those borders looking good. Let's go ahead and maybe make that line a little bit thicker. And again, in geom tile, so we'll do line width, and let's do 0.3. And I think that's a pretty good line thickness. We can adjust these things later on, of course, but I think we're in good shape. Since we're thinking about the color of these cells and kind of the border, let's go ahead and try to match it to the color in the original New York Times article. So this is the gray. I'll go ahead and copy that and bring that down to our scale fill manual. And we'll do breaks equals, and we'll do remain and cut, right? And then values. And we'll paste in that gray color. And then we also want this pink color, and we'll bring that in for cut. And now we've got our gray cells and our pink cells, but we notice that our NA cells are also a darker gray. Like I said, I want to get rid of those and turn those white. We can do NA.value, and I'm going to put in here white. So I could say quote white, or I could give it 6 Fs, which is what I'll do. I'm using hexadecimal for everything else. I may as well. And so now what we see is that those NA values have those white squares. Cool, huh? All right, so now what I want to do is start to clean up the background. There's a lot of stuff we still need to do. Don't worry, we'll get there. Let's go ahead and clean this up. The first thing I'm going to do is to turn off the expand. The expand is adding padding to the left, right, top, and bottom of each of these facets. So we'll get rid of that. We'll get rid of the grid lines as well as the background. So let's come in and we'll do theme, and we'll do panel.grid equals element blank, panel.background equals element blank. Of course, that gives us a white background all the way around. I still need, though, to come back up here and get rid of that expansion. And so we'll do chord Cartesian. I'll do expand equals false, clip equals off. Again, that expand equals false turns off the padding. Clip equals off will allow me to plot data outside of the plotting window. I find that I end up wanting clip to be off, so I'll go ahead and set that now. You see that our space is getting much better utilized here, right? And this is already coming together, I think, to be a really attractive plot. We still have some work to do. Let's go ahead and remove the axis titles, text, and ticks. Again, we can do that in the theme function. And we'll do axis.title equals element blank, axis.text equals element blank, axis.ticks equals element blank. And there we go. We've removed all of that extra ornamentation. So let's go ahead and put in the title as well as that caption. So I'm going to go ahead and copy this, and we'll create a labs function in here. We'll do labs, and we'll do title equals that. And then we have caption equals this long thing down here, and paste that in. And I think I forgot a plus sign after my labs function. Yep, sure enough. And so now we see that this is all kind of funny. The caption, of course, is right justified rather than left justified, and the title is running off the right side of the screen. I'm going to go ahead and use element text box simple for the title as well as the caption. Element text box simple does a pretty nice job of automatically putting in line breaks for you, so you don't have to do that manually. I've been doing that in previous episodes, and I think, why? Let's just use element text box simple. But to use element text box simple, of course, I need to do library ggtext. I really love that package. And so we'll do plot.title equals element text box simple, and then plot.caption equals element text box simple. And there you go. We have our nice wrapping of the text, both for the title as well as for the caption, right? And so one thing that I look to when I'm trying to copy what somebody else has done is basically, where does the line break occur? And let's then change the size of the font to match what they had. So we need to make ours bold. We also need to use Franklin, and I think we can then increase the size of the font. But let's go ahead and do Franklin and bold. So we'll do that here in plot title. We'll do family. Actually, I'm not going to do family here because we're going to use Franklin across the entire plot. So at the top of theme, I like to do text equals element text family equals Franklin. All right, get a comma there. And then we know that our title is going to be bold. So we'll do face equals bold. And so there we go. We have our bolded text. And we are ultimately going to change the if Social Security and Medicare are added as equal counts. We're going to make that reddish pinkish color. But I'm noticing that their line ends at R and ours ends at added. So we can make it a little bit larger font. And so let's come in here, and I don't know how big it is by default. I should learn these things. Let's do size equals 15 as a start. And that's actually pretty good. That's maybe a little bit too big compared to what they have. So let's take it down to say 14. And I think that is going to be pretty nice. Now let's go ahead and worry about this if Social Security, right? And so I'm going to grab my digital color meter again and get this darker pink color. So I'm going to copy that. And then I'm going to come back up to my labs. And then we're going to use a span HTML tag, right? So we'll do span style equals, and then single quotes because we're inside of double quotes. We'll then do color colon that hexadecimal semicolon close quote, and then we'll go ahead and close out the span at the end here. And there we go. Let's go ahead down to the caption, and that caption is a grayish color. And I noticed that theirs has more vertical space to it than mine does. And it's probably a little bit of a smaller font, right? So we'll come back to caption and we'll do color equals, I'm going to do gray 40. And I feel like that's too big. Let's go ahead and shrink it. So we'll do size equals 8. And it's probably, again, by my approach of looking at where the line breaks go, I think it's maybe a little bit too small. So let's up that to say 9. And I don't think it's going to be perfect. Maybe we can split the difference and do 8.5. All right, I think that's pretty good. Again, it's not going to be perfect reproduction, but good enough. They also have some spacing between their lines. So let's go ahead and do that. So let's see if we increase that line height. Here, let's do 1.5. So that increases the height of the font a bit. Let's maybe bring it down to say 1.2. And I don't know, we can play with this all sorts of ways. So let's go to 1.3 and I'll call that good. Let's put this line height on a separate line. Now looking at this, we want to add some margin to the bottom and top of that caption. So again, I don't want to go too crazy with all these margins and futzing, but there is a bit of space between the caption and the bottom of the plot, as well as where this legend is. So let's go ahead and add some space. So we'll do margin equals margin, T equals 10, B equals 10. All right, maybe that B equals 10 is a little bit too much. So let's go ahead and bring that down to 5. And I think that's going to be pretty good. Now let's go ahead and maybe add some space to the bottom of our title. So we'll come back to plot title. And here we can then do margin equals margin, B equals 10. And that gets us some nice space. Depending on where these titles fall out, we might want to add more space to the bottom of our title, but we'll see. All right, so now let's turn our attention to the labels for these different sections, right? We want, instead of Medicare in kind of a normal lowercase font centered with a gray background, we want it to be capitalized and bold and black and off to the left side with a white background, right? And similarly for like Medicaid, Obamacare, CHIP, we want this subtitle under it. Similarly for the non-defense discretionary spending, as well as other benefits to individuals. So to do this, we are going to use the labeler argument within facet wrap. And so that means that we need to create a vector that will allow us to map, say like Medicaid to this whole thing, right? And so to do this whole thing, we're going to be using element markdown then to bring in HTML to get the bolding, the different font, the different color for the different elements of these strip titles. So this part of the panel where this non-defense is called the strip. when you're looking at arguments within the theme function. So we'll come back up here. And I think what I'll do is I will add to this tribble, and I will then call this pretty. And then for each of these, I'm going to go ahead and copy in what they have for their title. So maybe I'll grab this first one to show you what I'm going to do. So like for this non-defense, I'll plop that in. And again, this then is going to be bolded. And so I'll put 2 stars around it. And then I'm going to use the HTML line break with the BR and bring this back up. And then this federal programs, contracts, grants, and employment is going to be a smaller font size. It's also going to be gray, right? And so here then I can do span style equals quote color colon gray 40. I'll use that gray 40 again. And then maybe we'll also then do font size equals, or colon, let's do 8 PT. So you need the PT when you're doing CSS styling. And then here we'll close out the span, okay? So again, if I run this, well, it's not happy because of all sorts of things, because I didn't finish everything else. What did I do? Oh, I don't have a comma at the end here. So now I'm gonna go ahead and repeat this for the other categories, and I will be right back. So I brought in those pretty versions of the titles, and I now though want to be able to go ahead and break this apart. And so I think I'm going to do that between the data creation and the plotting. And I'll go ahead and call that pipeline where I'm creating the data. So we'll go ahead and do data, getting assigned the tribble and everything that follows. So rerun everything just to make sure it all still works. That looks good. And then if we come back up here and take data, we get this, but that's not quite what I want. I'm gonna wanna break it up earlier. So maybe I'll call this budget on tribble. And that's gonna have my categories and my pretty stuff, right? And then maybe what I can do is I'm gonna have the categories being factors. I want that, right? So maybe here I'll go ahead and break it, right? And then data will get this with budget getting piped in. So we'll create budget here, which again, budget is going to have the category, the billions, the percent cut, the pretty, the bill cut, the bill remain, right? And then that budget's gonna get thrown into where we're creating the coordinates and the categories for the different facets. And then we'll go ahead and plot it. And again, that still looks right. All right, so again, if we take budget, so I'm gonna create a vector that's gonna be a named vector called pretty labels. And that is going to be budget, but I'm gonna do pull budget, comma, pretty. And so if I do pull budget pretty, that's gonna take the budget data frame and pull out the pretty column to become a vector, looking like this, right? But I need it to be a named data frame. So then I'll do names pretty labels, and then I'll do pull budget category, right? And it's not happy because I probably forgot to run this line earlier. All right, and so now I've got pretty labels where I've got a named vector, right? So this is the name of the first seat non-defense, and this is the value in it, right? And so now what I can do is I can come down to my facet wrap, and in here I can then do labeler equals labeler, and then I can do category equals pretty underscore labels. So this labeler function will take my pretty labels vector that I just made and feed it values of category to then get out pretty labels that it will put at the top of each of those facets. There you go. We've now changed those labels and they don't look like much, but hold on. And I think I'm noticing actually I forgot to put 2 stars to the right of Medicare and Social Security. So let's do that real quick here. We'll come back up here. Yep, sure enough, I forgot to add those 2 stars there. Get that loaded. And yep, all right. And so then what we'll want to add is a strip dot text element markdown. And so now we have our bolded title and our gray subtitle, but everything is center justified. So within that element markdown, we're going to want to make everything left justified. And so we'll come in here and we'll do hJust equals 0. I want to get rid of the margin as much as possible. So, and we might add that back, but for now, let's go ahead and remove it. We'll do margin equals margin, and we'll do zeros all the way around. And so then that brings it in pretty tight. I'm kind of looking at theirs. I notice that their title is a little bit bigger than mine, and that they've got a little bit of space. So maybe what we'll do is increase the size of the title font, right? So I'm setting the subtitle font within the CSS styling. So here we'll do like size equals, let's try 10. So that looks actually really good. I'm kind of impressed that I got that right. Then let's come back in to strip text, and then we could do line height equals 1.2. And then that will get some spacing between the title and the subtitle. Maybe that's too much, so let's maybe bring that down to say 1.1, and I think that's pretty good. I don't know that I changed a whole lot by doing that, but whatever, that's good. Now let's go ahead and remove the background, and we can then do strip.background element blank. Good, so that strips out the background there. I'm noticing that these are a little bit too close to each other, and maybe I want to reduce the line height. So what happens if we reduce this line height to 1? So I think that's okay. Maybe we want to add a little bit of margin to the top and bottom. The margin is really only going to be seen for these cases where we have a subtitle, right? So I said we would remove that, but here we are adding it back on. So let's go ahead and do like 2 and 2, or maybe we'll do 1 and 2, 1 to the top, 2 to the bottom. So I think that looks nice. We can make modifications later to increase the gap, say between like the bottom of the defense grid and the top of the Medicaid. But there's other things we're going to want to play with first, and I don't want to get too far ahead of ourselves when we start doing that. All right, so the next thing that I feel like we need to do is go ahead and add the legend to the bottom of the plot. So you'll recall that in geom tile, I did show legend false. So if I bring that back, we find that that puts that to the right side, right? But it also has these two categories, and I'm not really sure how to get rid of these two categories. So I think what I'm going to do instead is create a point that is a gray point in the Social Security panel, okay? So let's go ahead and remove that legend again. So we'll go ahead and remove that comment. All right, and so I'm going to put a point down here below Social Security, right? So I'm going to use geom point. Ordinarily, I might use something like annotate, but because I have these facets, you can't use annotate with facets. And so I need to create a special data frame that only has the category Social Security, that's going to have column 1 and then row like -2, right? So let's go ahead back up here, and after geom tile, we'll do geom underscore point, and we'll do data equals a tibble, and our category will be social underscore security, and then we'll do call equals 1, row equals, let's try 1 for right now, right? And then we'll also do budget equals remain, put that in quotes, and then our AES is all going to be the same, except if we did like color equals budget, right? And then we could also then do shape equals square. Normally I put in a number, but hey, let's try putting in the word. So let's try this and see what we get. So what you see in the lower left corner then is a tealish square for that point we just put in, right? So I'm gonna come back and say that we also want to turn off the legend here because we got those legends and I don't really need it. So we'll go ahead and do show.legend equals false. Also go ahead and remove this AES for the color because that's not important because we only have one color. So let's set that to be the same gray that we used here in our scale fill manual. I'll go ahead and copy that and paste that in. And now let's go ahead and drop the row. So that was at 1. Let's go ahead and put it at say like -2. So something I noticed when I did that was that we instantly got more space between our facets. And that's not real. We did get more space, but if I turn our background back on, what I notice is that it is expanding the Y scale for all of the panels. And I could turn off that rescaling of the y-axis. I could basically give each facet its own y scale. But it's going to then make the size of the squares different in each of the panels. The height of the squares is going to be different in each panel. I could get around that by doing facet grid, but with facet grid then, I wouldn't be able to put my titles on top of each of the plots. It would put the titles off to the right, which isn't what I want. So I'm going to make do with this, and I think it's going to be okay to have that extra space there. So let's go ahead and turn this panel background back off. So the other thing I'm noticing is that we've got rectangles rather than squares for our plotting symbols. And we'll want to play around with that here in a minute. Maybe what we could do right off the bat, though, would be to come to chord Cartesian and do chord equal. And so chord equal will make the row height the same as the column width. And so that then brings everything in, and it gives it just a really weird look, right? And so we'll want to play with this some more. I'm going to leave it here because I'm going to be adding my legend title, and we're going to perhaps be removing some of the space between our facets. So let's not freak out too much just yet. Let's go ahead and add in that legend title. But hopefully what you can see now is that all of these squares are the same size, right? And so let's come back up, and just like we did this geom point, we're going to do the same type of thing, but we're going to do geom text, right? And so we'll do geom text, same category, same budget, although this budget remain doesn't really matter. We're basically doing that so we don't have to do inherit AES equals false, whatever, it's not a big deal. And so here, what we're going to want then is label equals, and then we're going to want this, right? And so we'll go ahead and grab this, and copy that, paste that in. Again, that's really long. Make sure we've got a comma. Let's put the color back here, get everything to line up. And the other thing we're going to want is family to be Franklin. And then let's go ahead and do size equals 8, and then size.unit equals PT. And so we now have our legend, but of course it's centered on that point. And so we need to move it over a couple of columns, right? So again, I have column 1. Let's put it at column 3. And then let's also come in here and do hjust equals 0. So that then, of course, left justifies it to column 3, probably too far over to the left. Maybe we'll go ahead and bring that in here in a minute, but I'm going to go ahead and manually insert a line break. And so their line break comes after non-defense. And so we'll do a \n there. And I'm seeing that I need more space between my caption and the bottom of the plot. So I need to add some margin there, right? And so I think we'll do that in caption at the top. Let's go ahead and take this up to say 20, and that's looking good, but it's vertically justified at the middle of the point, and we want it to be at the top of the point, right? And so we'll come back up to geom text and vjust. I'm going to try 1. And so that actually puts it below the point, which is odd. So we'll move it up a little bit. So let's do vjust equals 0.8. Pretty good. Maybe it could come down a little bit. Let's take it to 0.9. And then let's do line height equals 1. And changing that line height brought it down. Let's take it back and let's do vjust equals 0.8. So now the problem is that because our coordinates are equal, everything is kind of behaving a bit weird. And so what do we want to do? I think what we want to do is go back to chord Cartesian. So we'll make this Cartesian. Of course, that stretches things out to make things look like rectangles. And I have 7 rows. And so I think it might actually be easier to interpret if I have 5 rows, because then each column will be $25 billion, right? I think I did the 7 based off the Social Security data that they had in the New York Times' original version. So let's take this down to 5. And this is complaining in index 5 caused by error in bind rows. Okay, so we need to do some troubleshooting. So in index 5, I think that is the 5th value. So that would be in Medicare. And I wonder if we're going to run into a problem because we have a value in billions that is already divisible by 5, right? So let's go ahead and look at our data. Oh, we can't look at our data. Let's look at our budget, right? And so let's come back up to our waffler, and I'll do D is a tibble, and we'll then have that be budget, and we'll have cut and remain, and then we'll have billions, and that is going to be 840 and 160. That'll be 160 and 840, right? So there's our D. And so if we kind of step through this, again, our n rows is going to be 5, right? So, right. So let's try this again. N calls, N and A. So if we do N calls, it's 200. And then our N and A is going to be 0. And I think that's wrong because I don't think that divided by the 5 to get the scaling factor, right? Where do I do that scale factor? Oh, right here. Right? And so I need to divide in my D. Let's grab that D. All right, where were you, D? Here, and then we'll do this divided by 5. So we've got 32 and 168. Okay, now let's come back up to Waffler and step through this. So N calls should be 20, but it's 40. But does that make sense? No, it should be, so that should be 40, which is right because 32 and 168 is 200. We've got 5 rows. That's 40 columns, right? And so then our N and A is going to be 0, right? And then we've got uncount, D, and billions. And then we're going to go ahead and arrange that, right? And maybe what we need to do is to split this apart because we don't need to do this part if N and A is 0, right? So let's go ahead and call this D, and we'll go ahead and come here. So we'll do if N and A not equal to 0, then we're going to then say D is bind rows of D and tibble. All right, and then we'll go ahead and close out that if statement. Otherwise, we're going to bind calls with D and expand grid on that. So let's see if this gives us any error messages when we run it through. That skips that, and then bind calls, that works. All right, now let's see if that works with everything. Hey, there we go. It worked without complaining. What do you know? And going down to 5 rows makes my cells in my waffle plot look pretty square. I think that's pretty good, right? And so again, each column then is going to be $25 billion. So let's go ahead and move our legend back to the left a smidge. And again, we can do that here in geotext. I put that in column 3. Let's put it in column 2. That brings it over. I think that's pretty nice. Then what we want to do is remove some of this space between our different panels, right? So I think I had a margin at the top. I had like 1 unit. So let's take that to 0. Doesn't do much, right? And then we can come in here and we can also then do panel.spacing.y. And this controls the vertical spacing between our panels, right? And so we can then give it unit. And if I give it like unit 0, I think that should bring them in a little bit. Oh, and I didn't give it a unit. So this should be in PT. So that brings in a little bit. Let's see if we can give it a negative number to bring it in even closer. So that's 0. Let's do -10. And that brings it in. And I think this is looking really good. I'm pretty happy with the way this is coming together. But I am noticing that as I do that, my squares are getting tall and rectangular. And so maybe what I need to do is reduce the height of the overall figure to effectively make it a wider plot, right? So let's come back here. And so I have 7.35. What happens if I make it 7? So that brings it down, but they still seem a little bit rectangular. So let's go to like 6.8. So it's still a little rectangular. Let's go to 6.6. So those look like pretty good squares. One thing I'm noticing is that my plotting symbol now is smaller than those squares. So let's increase the size. So again, that was actually a point, right? So let's go ahead and do size equals 3. Okay, that's too big. Let's go ahead and make that 2. I'm gonna call that pretty good. So maybe they're still a little bit too tall. Let's go ahead and make this like 6.4. So zooming in, those are definitely square. My plotting symbol is a little small, but I'm not gonna worry about it so much. So the final thing that I wanna do, and I realize this video is already getting too long, is to put the percent cut kind of up here in the upper right corner. Could think about perhaps putting it as part of the title, but I don't know. I don't think I want to do that. I think I'm going to be happy for now to put it over here on the right. I think putting it as part of the title is going to really drag this video on quite a bit longer. I think I'll leave you to work on that yourself. You might also say, like, what's the point? Everything has 16%. I could imagine a case where you want to take the code and you might want to fine tune some of the cuts, right? To maybe make, well, actually things have moved around, haven't they? Like this non-defense had been at the top, so we need to fix that. But you might want to make this like 50% cut and then make some of the other things less, right? And so you maybe don't have a uniform percent cut across everything. I'll let you play around with that. So I want to fix the order of this, and I also want to go ahead and put in those numbers. And I think I know what the problem was. I think the problem was back here with geom text, was that I used category of Social Security for geom point and geom text without making it a factor. So let's go ahead and make it a factor. And I think that should fix the order of our stuff. And come back here and do it for geom text as well. And get that in, bring that down. Good, that now put our non-defense discretionary spending at the top and got our order to match their order, right? All right, so now let's go ahead and put in that percent cut. So we'll come back up here. And again, we're gonna want to probably make a pretty data frame. So if we had like budget, right? So we're gonna have our category and our percent cut. So let's do pretty cut. I'll hold on to that for right now, but we'll take budget, we'll do select, category, and percent cut, right? So that's gonna get us a data frame like that. We need to get an X and a Y position, right? So our Y position, we could do like mutate, and that's gonna be the row, right? And so I'll say like n row plus, I'm gonna just put it at n row. And then I will use my vjust to move it up, right? To be above the plotting window, right? And actually that needs to be Y, not R. And then our X might take a little bit of extra thought, right? And so what we want to do is take the largest value in the billions column. And so maybe I'll pull this down for now because I still want access to that billions column, right? So I'll do max on billions, right? And so that's going to be, in this case, like 1664. And I'm going to divide that by scale factor, and then divide that by n row. And I'm then going to do ceiling on that, right? To get effectively the column. And so if I look at that, Y must be a vector, not a function. Oh, n rows, not n row. All right, need an S there. And it's still unhappy, and I hit the wrong thing. All right, so ceiling error caused by max billion scale factor n row. So that should be n rows, right? All right. Now what we get is category X and Y. We see the X and Y positions are the same. Now what we can do is go ahead and pipe this to our select, and we'll then want category X and Y. Good. And so we'll then assign this to pretty cut, load that in, and then we'll come back down, and after geom text, we'll do another geom text, and we'll do data equals pretty cut, and we'll do AES, X equals X, Y equals Y, label equals, well, I need to make the label, right? So I'll call this label, but I need to make it, right? So we'll come back up to pretty cut, and we'll do label equals, and I'll go ahead and do paste %_cut, and then %, space cut. And I'm going to use paste 0 because otherwise it's going to put a space between my 16 and my percentage sign, right? And then we also want to, instead of %cut here, I want label. All right, so we load that, we look at pretty cut, we've got 16% cut, which will match what they have in their version of the plot. All right, good. So again, we're going to come back down. This all looks good. We'll add this in, and let's see what this looks like. It is unhappy. If I had to guess, I need to do inherit AES equals false. So that error went away. And so now I see I have my 16% cut, but again, it's centered on that coordinate. So let's go ahead and make it right justified. And we'll do that up here. We'll do HJust equals 1 to be right justified. Let's also go ahead and do family equals Franklin. Again, if you're changing the fonts are handled differently in the geoms versus in the theme function. So we'll do that here. We'll also go ahead and do font face equals bold. Again, here in the geom text, it's font face bold rather than face equals bold down in theme. Don't ask me, I don't understand. And then we'll do size equals, let's go ahead and make it the same size as the title for the strip. And so what was that value? So strip text size 10. So we'll do size equals 10, size.unit equals PT. And so there is my text, good. Now what we want to do is I think we also want to move it to the right a bit, because if I had to guess, this square is centered at 20 or whatever it is. And so it needs to be over just a smidge, maybe like 20.25. And so we can come back up to pretty cut, and that's going to be the X position, right? So maybe I won't make it, maybe I won't modify the Y position. Maybe I'll modify the H just, make that like 1.1. So that moved it left. So let's make it maybe 0.8 to move it right. Okay, that's too far. Let's make it 0.9. And maybe we'll just go a little bit more to 0.95. And I think I'll call that good. All right, so I feel like we're getting there. So now we want to move it up vertically. So let's go ahead and put VJust in, and let's do 0. All right, so I think we want to make it more negative than 0, and that will move it up above the plotting window. So let's do negative 0.2. That moved it up a little bit. Let's go a little bit more. Maybe we'll try a negative 0.5, and let's go more. Let's go negative 0.8. So I think that's probably pretty good. Let's go ahead and give it that pink color. Not this one, it's this one here, right? It's a darker, brighter pink. I'll go ahead and copy that. And then in here, we could do color equals that. This is my version of the plot, and this is the original version of the plot. I, of course, like mine better than theirs. The main reason I like mine better than theirs is because it allows me as a viewer to more easily compare the categories to each other. With the one on the right, the original from the New York Times, I have to compare the number of rows where there are also fractional rows, right? Whereas on the left, I have to compare the number of columns. And it's very easy to mentally rank these. I might even go back and rank these by the size of the different categories, right? I think they put the non-defense discretionary spending at the top because that is what Musk and Doge were going through and trying to cut first, right? And so then everything else kind of falls from that. Again, I think this is pretty cool. Waffle plots are interesting. I don't think they have the problems that a pie chart has. At the same time, I don't know. I don't know what I think. I think it's cool. I think it's a different way of doing it. This is a bit different for me. I've never made a waffle chart before. And so this, again, is a little bit different for me, and maybe it takes my head a little bit to wrap around what's going on here. But on the whole, I think it's pretty cool. Again, the one thing I would probably want to change is probably putting the cut next to the title. That's going to take a fair amount of extra work, I feel, that I don't really have the time to. This video has already gone too long. One other thing that I think would be really valuable, and I'm kind of surprised New York Times, and I don't know if anyone else did, would be to let the audience member pick the percent cut for each of the different categories to see if they could get to $1 trillion. And so this might be a place where using something like a Shiny app would be really handy to let people play around with the budget and doing budget cutting, right? And to think about what category would you cut and by how much to get to $1 trillion. I think in the end, he got to basically $250 billion, and that's about as far as it got. And then he kind of quit, right? He gave up and realized that it's kind of hard to run a country, right? So anyway, no easy decisions. There's lots of debate, of course, of whether or not we should be making cuts, lots of debate as to whether or not we should be increasing taxes, whether or not, Musk, does he actually pay enough in taxes? I don't know. I'll leave that out there for people to discuss. But again, I like what we came up with here for this waffle chart. I will start thinking about where I might use waffle charts in my own work. If you've seen cool waffle charts out in your reading of your scientific literature or reading the media, let me know. I'd love to see other examples of where people have done a pretty effective job of visualizing data with the waffle chart. All right, that's enough for today. I really hope you've enjoyed this video. I would love it if you've made it to this point. If you could please like this video, subscribe to the channel, and tell your friends about what we're doing here. Anyway, I will see you next time for another episode of Code Club.